There we go. All right. Right. There we go. Right. So our session today, as I have said, folks, that will be based on functions, but there are some few rules that I want us to look at. But before we go to rules, all of our sessions will always start around about 9. As you can see that the time is 9, even though I'm a little bit late at our time, or every day from Monday to Thursday to Friday, right? Then, as I said, that your presenter, I am Prof. Sbia, Mr. KWV Sbia. Then if you want to ask me questions after this session, obviously you can Twitter me at WTS Twitter, or you can simply WhatsApp me on my number there. You can see my number there on the screen. It's 08267 27928. And the functions, as you can see there, the functions on its own, they are plus or minus 35 marks. That is what we'll be busy with. And it is very important to score all of these marks, right? Or at least we say 80% of these marks. But however, there is no way, if you can understand me very well, that would let you fail to take all of this plus or minus 35 marks, right? Then, folks, let's move to the next slide. Okay. Now, what are the rules of which are very important? The first one is the one of saying, as we are here, folks, we are here to learn, so we have to respect each other. And you must always feel free to ask any question, right? You can ask any question that you want to ask. But then how to ask the question, what you have to do is to raise your hand and you'll be unmuted. Then you'll be in a position to ask the question. All right. Please keep your cameras or your videos off. That is also what is very important. All right. And if obviously you are shy to ask, using your voice, you can always write on the chat. Okay. That is another option. We will not tolerate, obviously, the vulgarity. Then, what is also important in order to join all other classes of our classes, because we are not only dealing with the maths and science as a STEM lockdown digital school, we cover all subjects. So what you have to do, you have to subscribe so as you get all the newsletters update based on the classes and the link as well, right? Then that's all. What are our objectives for today? At the end of this lesson, this is what you should understand. It's what we call quadratic function. A quadratic function, we sometimes call it a parabola function. Okay, the effect of the parameters, which is A, P, and Q, right? You have to know how to complete the square, and I'm sure you did that one in grade 11, how to complete the square. Dual intercept method, you also did that one in grade 10. The dual intercept method is x-intercept and the y-intercept, which is something that you understand. Right, sketching of the graph, obviously, increasing and the decreasing of the graph, reflections and translations, domain, and the range. Then after that, there will be a homework. Okay, let me show you our homework. I took this question from one of the past papers because at the same time, I want you to understand, to know exactly how then the questions comes on your paper. So that's why I took our homework from the past paper. Obviously, the TPE past paper, I cannot tell you exactly because I know you would search that question. But what is important here is for you to try this, because before we start tomorrow, what I will do, I would allow you, or we'll go through all of this so as you would understand, right? So we'll go through this question tomorrow, but it is very important to try it before we proceed. Right, so this is your question. Obviously, you can take a photo of this one or a screenshot. Because of time, I cannot allow you to copy this one. But the first question asks you the turning point, y-intercept, x-intercept, sketching of the graph, determine the values of k such that your f of x is equal to k has equal roots. Now we're talking about the nature of the root, which is very important as well. Right. Then, and the shifting of the graph, that is transformation. Right. So that is that. Then after that one here, let's go to this slide. Now we are talking about what we call keynotes, basic skills. What is it that we have to understand? That should strike to that one. Okay, keynotes there, we talk of domain. We have to know that domain, we talk about the set of possible x values. The range, as you can see there, the range are the set of possible y values. Axis of symmetry, obviously that is a y value of a turning point. I'm sorry, it's an x value of a turning point. Maximum, it's a y value of a turning point, but it's the highest one. But the minimum is the lowest y value of a turning point. Then we talk about asymptotes, obviously, and the turning point. Right. And this slide of transformation, okay, talks about horizontal transformation, vertical transformation, and also the reflection. But obviously, I would explain this on our notes because this is very important. Right. So, folks, let's start our lesson. Here is our new slide of blank one. We are saying today we are looking what we call parabola, or we call it quadratic. So for sorry about my writings, quadratic functions. Okay, sorry, the slide is moving a little bit. Right. Okay, functions. Okay, right. The quadratic one, we said it's a parabola. This can be in a form of y equal to ax squared. Okay, or okay, we say this is in a form of ax squared or this can be in a form of what? This can be in a form of y equal to a x squared plus q. Then the last one is this form, which is y equal to a x squared plus bx plus c. Well, I talked about what we call parameters, which is a, obviously. Okay. Then what is it that you have to understand about a? We are starting about a. A will tell you more about what we call shape. Okay. That's the shape of the graph. Right. Then what is important with A, as I'm saying, is that A will tell you more about what we call the shape of the graph. Now, your A can be positive. Let me start whereby A is positive. That is where A is greater than 0. If something is greater than 0, obviously it's positive. Okay, that is that. Right, let me give you an example of that one. This can be y equal to, say, x squared. You can see here that our A is 1 and our A it's positive. Or our A obviously can be negative, which is the sign which is less than 0. Okay, that is negative. Obviously, this one can be something like this, y equal to, maybe let's put negative 2x squared. You can see that our A is negative. Now that is the meaning of A. Now let's take the first one now, whereby our A is greater than 0. Now I'm trying to recap what Ms. Shabalala did. Right. Now if A is greater than 0, okay, if A is greater than 0, okay, let's take an example. If we have y equal to x squared, right? Then your shape of this graph will be concave up. The concave up, it's something like this. This is your concave up. If I can throw the Cartesian plane here, just a rough one. This is your Cartesian plane, right? You can see that this graph it's a happy one, right? So which is a concave up, and obviously this what is important with this one is that it will give us what we call a minimum value of what? Of y. This will give you what we call a minimum value of y. That is the y value of a turning point. Right. And another thing that I want to take note here is that if you look at this curve, our x here, of which is our axis of symmetry, of which we said it's a turning point. Our turning point here for the x value is what? It's 0. So now, as you can see that here, our x is 0, but moving from your left, if you look at this curve, you can see that our curve here, it's decreasing, which means whereby our x is less than 0, what is happening to our curve? Okay, sorry about that. Our curve here obviously is decreasing. Okay, let's indicate that one. It's decreasing. Right. It's decreasing. Right. But then from this side, look at this, the other side now. Okay, let me use another color source. You will see from your right, okay, whereby our x now, it's greater than 0. you can see that your curve is what? It's increasing. I'm sure you now understand about this thing of increasing and decreasing of the curve. So that is what is important to take note of. Right. Now let's look at the scenario whereby our A now is less than 0. Okay. This is a scenario whereby our A is less than 0. It would be something like this. We are saying here, okay, let me go back to my red now. Okay, here our A is less than 0. That is when you have something like this, negative x squared. Right, your shape in this case, this is our Cartesian plane. It will be something like this. Okay, right, and you can see that this is a set face, right? We call it a set face. But what is important here is that your y value of a turning point. Now, the y value of a turning point is at what? At maximum. That is a what? That is a y value of a turning point. The y value of a turning point. It's at what? It's at maximum. Right. Then, but again, you can talk about if we can go back to what we did last time. We said your x is what? It's 0. However, if you look at whereby your x is less than 0, you can see that your curve, this one, it's increasing. Now it's an opposite. You see, moving from your left to your right, the graph is increasing. So now we talk about the increasing function. Okay, but this side, whereby your x is greater than 0, right? Whereby your x now is greater than 0. Here we talk about what we call a decreasing curve. Okay, one can ask to say, sir, how can I see that the graph is increasing or the graph is decreasing? Okay, let me explain. As you move from here, going up, you can see that your x values are increasing and also the y values are also increasing, which means both x and y are increasing. So that's why we are saying this is the increasing curve. But moving from 0, going this side, you can see that as the x increases, right, your y decreases, right? So that's why we are saying that is what we call a decreasing function. That is what is important. Now, let me add another slide because I want you to understand this thing of shifting. But now I'm sure you understand, you can be in the position to see that your graph is increasing or your graph is decreasing. I'm emphasizing from what Ms. Shabalala said. Okay, right. Now let's look at what we call transformation. Okay, now we are talking about transformation. That is transformation. Okay, now we are transforming the graph. Okay, you can transform your graph up or down. Okay, if we talk about up or upward transformation, you would see, okay, this is whereby you have something like this, f of x plus q. So if we are saying you want to transform f up units, that is where your q will be greater than 0. But that's a down transformation. That is where your q will be less than 0. Okay, let me give you an example of this so as you understand. This is the first one that I want us to look at. Okay, let's take our function, which was y equal to x squared. Let me transform this graph. Let me say 4 units down. Okay, if I say -4, so this is 4 units down. So now this means our graph would be something like this. This is a Cartesian plane, so it could be something like this. Okay, this is our curve. Right. And we said this is our y-axis, this is our x-axis. That is what Mr. Balala said to you. Then, if you look at this one, now what is your turning point of this graph? Your turning point of this graph obviously is given by, okay, let me use the black one here so you would see. Our turning point here is 0 and negative, sorry. Slide can move. Okay, yes, it's negative. I mean, it's 0 and -4. What is that? That is our turning point. And if you want to understand the decreasing or the increasing, you can see that this curve, where x is 0, the graph is decreasing. But from here, your graph is obviously increasing. And this is a happy face, which means this will obviously give us what we call your y, which is -4, is what we call a minimum one. Okay, right. And now let's look at the last transformation before we look at our activities, because I still have one activity that I want us to cover today. Right. Now let's talk about this transformation. This one now is the one where the graph will be transformed to the right, or your graph will be transformed to the left. Okay. Here we talk about something like this. This is a into x plus what? Plus p all squared. Right. Here, this is what we have to take note of. Let me give you an example. Let's proceed with our example of x squared. Let's say you have, this is x squared. If now we want to transform this one to the right, what we will do here, we want to transform it to the right. Okay, let's say this graph is transformed 2 units to the right. So that means our x is what? Is 2. So which means that we are now transforming our graph 2 units to the right. However, our factors should be always equal to 0. So this will be something like this. This should be x minus 2 equal to 0. Oh, there we go. This says where there is x. Okay, let's put the square first. Where there is x, you put what? X minus 2. Wow. So if you look at the value of p, you can see that the value of p here is what? It's negative. So if the graph is transformed to the right, that means our value of p will be less than 0. Right? But now let's look at the left. We want to transform our graph to the left. Let's say this graph is transformed 2 units to the left. We put -2. However, we said this one should be always equal to 0, which means you have to take 2 to the left. So this would be x plus 2 equal to 0. Wow, there we go. Now this means where there is x, we have to put what? X plus 2. Now our function will be something like this. This will be x plus 2 all what? Squared. Wow, you can see that your p now is positive. This means if you want to transform your graph to the left, or how can you see that your graph is transformed to the left? You simply look at your p. So your p there will be obviously greater than 0, which is the number which is positive. right? So that is that, folks. Right. Now, let me talk about the last portion, and then we'll shoot straight to our activity because of time. Now, I want us to remind you of what we call a reflection. Okay, this is very important for grade 10, grade 11, and grade 12. Okay, we are now talking about what we call a reflection. Okay, this is the reflection. Okay, reflections is divided into three. However, for today, we'll simply look at that is a reflection across the x-axis and across the y-axis. Let me check the Cartesian plane. Let's say you have this. Obviously, this is your y-axis, and this one is your x-axis. Right. Let's say you have a point here. Okay, let me first explain this. This is 0. Yes. Moving from here to your right, your x values are what? Are positive. All right. But this side, your x values are what? Are negative. Obviously, your y are positive. This side are what? Are negative. This is what you know. Right. Now let's take a point, any point, but in terms of x and y. Let me put it here. Let's say you have x here and y. Let's transform this graph or this point. Let's say this point is A. All right. If we transform it or if we reflect it across x-axis, look at this. It will be in this quadrant, which is a second quadrant. Now, look, your x here, it's what? It's negative, but your y is still what? Positive. There we go. This is what is important. So if we talk about the reflection across the y-axis, obviously what is changing? Your x is changing. That is that. But now, if I reflect this point here, okay, this is this. Let me just use one line. Your x is still positive, but your y is negative, which means the reflection across the y-axis only affects, across the x-axis, only affected the what? The y. But graphically, when we talk about the reflection across x-axis, we are saying your x is affected, so this would be something like this. This would be y equal to f into minus x, which means where there is x, you put a negative. But the x-axis, obviously, here, this will be y equal to, we said for the x-axis, what will be affected will be y. So this will be minus into f of x. That's all. Okay, let's stop there with our explanation. Let's simply shoot straight to our question for today, which is our classwork that I want us to do it together. Right. Now, first, let's look at our classwork. It's only one question, and we will try to cover everything here. Right. Here is our question. Okay. This is our question. The question says, given f of x, right? Our f of x is given by minus 2x squared minus 5x plus 3. What is our first question? Our first question here, right? Our first question says rewrite f of x in a form of, right? In a form of what? A into x minus p all squared plus q. Okay, I'm sure you did that one with Ms. Shabalala, but that is where you complete the square. Let me show you how to complete the square. But you do that by what? By completing the square, right? Okay. Now, let's simply write our question here. Our equation is given by, which is our classic, is given by f of x equal to negative 2x squared minus 5x plus 3. Okay, we are saying we have to complete the square in order to write it in that form. Right. How to complete the square? Let's go back now to grade 11 work. Okay, grade 11 work. If you complete the square, you have to make the point that the coefficient of x squared is 1, but in this case is 2. So what is it that you have to do here? You have to take out negative 2 as a common factor. Then you divide everything by negative 2. Obviously, this would be x squared minus, but you say negative and negative, this would be positive. This would be 5 over 2x. So you divide everything by what? By 2. And this would be minus 3 over 2. So what's your first step? You first take out x as a common, negative 2 as a common factor. Then what next? You take this number, or the coefficient of x, you times by half, then you square. So this would be minus 2. This will be x squared plus 5 over 2x plus, then you square this one. You did this one on the first term. You divide by 2, then you square. You also subtract it. This is minus 5 over 4, all squared. Obviously minus 3 over 2. Then you close the bracket. Then you factorize this one. This is minus 2. How to factorize this one? It's very straightforward. Then you look for your factors. This one. This will be what? You factorize. This will be x minus 5 over 4. Then you use your calculator here. Okay, let me try to break this one down for you. This will be negative 25 over what? Over 16 minus 3 over 2. Okay, you simplify what is inside there, right? So what will be this? This will be minus 2. This is x minus 5 over 4, all squared. And then this will be minus, this is all over 16. Then now it is very important to use your calculator, obviously, here, so as you will understand. Okay, then this will be 2 times 25, that is 50. However, that you minus what? That will be 50 minus 3 times 16. Let's use our calculators here and see what will be our answer. Okay. Minus 50. Okay. Then what you do here, you cross multiply. This will be 2 times this one. Obviously, this will be 50. This times this will be negative 48. Then you close the bracket. Then let's remove the bigger bracket now. Okay. This will be your y equal to, okay, let me first rewrite this one. This is x minus 5 over 4 all squared minus Then what you will do, okay, let me firstly rewrite this step. So as you would see, it's 50 minus 48, right? It's 50 minus 48, but let's put the minus, okay, all over, okay. Let me go back a little bit. There's something that I want to correct there before we move very fast, okay? Because of time, I just want to cover this one. Let me go back. Where is my eraser here? Because I can see I'm missing out here. Okay, let me remove this step. Okay, let me go back to grade. This is grade 10. You look at the LCD here. What is your LCD? It's 16, which means you multiply this one by 8, okay, and also this one by 8. So as you would have what? 16, right? Then hence this would be what now? This would be 25 minus 24. Then obviously you simplify that one. However, we are saying you can obviously use your calculator there. So you simply complete the square. All right, so erasing this one. Okay, I don't have a calculator with me, so that's why I'm struggling a little bit here. So you subtract this one. This would be minus 25 and minus 24. Obviously, that will be minus 49. There we go. So this will be minus 49 over minus 49 over 16. Okay, sorry, this one is jumping over 16. Okay, let's go back to our black. What you do now, you remove the bracket. Okay, you multiply by 2. This will be negative 2 into x minus 5 over 4 all squared. Negative some negative, this will be positive, obviously, 49 over 8. Oh, that's all. Right. Then first, what we have to do now for your B, what are they saying is that hence write the coordinate of the turning point. Wow, that is very straightforward. The turning point, we said, this is what Ms. Shabalala said here. The turning point, you equate this one to 0, and this you take this one as it is, which means the turning point would be x minus 5 over 4. You firstly equate it to 0. Then your y obviously would be 49 over 8. Then what will be your x here? Your x, you transpose, your x will be 5 over 4, and your y is that one. But we have to write this one in a coordinate form, which means this would be 5 over 4, and what? And 49 over 8. What is that? That is your turning point. Wow. I'm sure you are still following. Right. Now let's look at the next question. Okay, but before we look at the next question, what is it that we can conclude from here is that if you have something like this, x plus p all squared plus q, then for the turning point, what you will do, you'll take what is inside the bracket, equate it to 0, then your x will be minus p. That's your turning point. And you take y as it is. Okay? You take your y as it is. So this will be what? Your y will be q. So that is what is important. Now let's move to the next question. Okay. Now our next question says, folks, let me go back to this slide, which is C. Says, write down the coordinate of the y-intercept. Okay, what do you do for the y-intercept? Okay, this is C. The y-intercept, obviously, what you do, you let x be what? Be 0. That is what we call dual intercept. So if you have something like this, y equal to negative 2 x squared minus 5x plus 3. What you will do here, where there's x, you put 0. This will be minus 2, you put 0 here. Minus 5, you put 0 here, plus 3. Obviously, your answer would be 3. Wow. So our coordinates here would be 0 and 3. Okay. Now, for D, it's what we call, the question is looking for the x-intercept. Right, the x-intercept, what you do for the x-intercept, you let y be 0. This is same as f of x equal to 0 because the f of x is same as y. So what you do here, you put 0 here, this will be negative 2x squared minus 5x plus 3. What next? You look at the factors. Okay, let's factorize this one. Now we are going back to term 1 work. This is 0 equal to negative 2x squared minus minus what? Minus 5x. Okay, I'm sorry here, my slide is moving. Okay, we are taking this one to the next slide. There we go. This is 0 equal to negative 2x squared minus 5x plus 3. In order to solve for x, obviously, you transpose this one. So this will be positive x squared plus 5x minus 3 equal to 0. Obviously, you look at the factors, of which I can even advise you to use your quadratic formula if you cannot factorize. But the factors for 2, x squared is 2x and x. The factors for 3 obviously is 3 and 1. The bigger product would always take the sign of the middle number, which is positive here. So this one should be positive and this one should be negative, which means your x here, your 2x is equal to 1, or your x is equal to minus 3. Now what you will do here, you will divide everything by 2. So your x is 1 over 2, or your x is negative 3. So in a coordinate form, this will be half and 0, and this will be negative 3 and 0. Okay, there we go. Okay, first, let's stop here for now. Okay, what is our next question, which is E? Okay, let me show you our next question. Then we left with 15 minutes, but obviously we'll be in a position to cover everything. What is our next question now? Okay, we did C, which was asking us our y-intercept, D, which was asking us our x-intercept. Now, E, it's asking us what we call axis of symmetry. And we said the axis of symmetry is the x value of a turning point, and we already calculated that one. Okay, then let's look at F. Hence, calculate what? The maximum value of a turning point. All right, the maximum value of a turning point. We already have that one. So now what we have to do is to simply write it down. In fact, what I wanted you to understand with this question is that when we talk about the x value of a turning point, basically we are talking about what we call axis of symmetry. When we talk about the y value of a turning point, we are talking about what we call the maximum value. It can be a maximum or a minimum, right? Depending on the shape of the graph. But since our A here is it's negative, obviously it will give us a maximum because it will be a set phase. It will be something like this, right? Now, there we go. Let's write this one down so as you would understand. Okay, we are in number E. Okay, whereby we are expected to write what we call the x of symmetry. Then we have our equation here, which was negative 2 into x plus x. Okay. I don't know this thing cannot write. It was X. Don't know what's wrong with my slide. Ish, ish. Okay. 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 We'll proceed to